You got Bono, and he's having a tug of war with Buzz Aldrin from the movie Apollo 11. And they're pulling either way 10 newtons. Actually, I should really put minus in front of that 10 newtons left because it's going backwards. Okay, now anyway, there's no winner and it's a draw. Okay, so what about if it's a diagonal? That we have to split up into components. It's kind of like when you squeeze an apple pip. The two forces act diagonally to create one horizontal force, and the pip shoots out. So we're going to break up our diagonal there into vertical and horizontal components. Let's say we get one of about 10 newtons at 60 degrees, okay? How do we find out what those components are? Well, it's not that bad, actually. So a memory trick that I use is I think of a picture of a sky and a car. Car along the horizontal and S for sky along the side. You see, that actually turns into C for car cos of the angle at the bottom, and S for sine, skyscraper, sky, whatever you want, is a vertical component, okay? I then just put the magnitude of the force, that's the 10 newtons, in front of that. And that's it. That's actually how you find the components. So the horizontal component is always the magnitude of that diagonal force, in this case 10, the red one, times the cos of the angle, 60. And the vertical is always the magnitude again times the sine of the angle. The only trouble is remembering which is sine and which is cos. But as long as you remember C for car, across, S for sine, up, that gets out of most very simple problems. So we just bang those out on the calculator, and your answers, plug them in for the components. So we got 5 either side, and yeah, there we go. So there are components. Let's have a go at this question again. We're going to do the splitting up of this 20 newtons into components. What was it again? It was, oh yeah, C for car along the bottom. So F, the force, cos theta, the angle, and it was sine theta was vertical, skyscraper gradient. So I'm going to plug those in and then kind of fill them in as we go. And we're going to use 60 again. Oh, it's not really 60. I know I probably drew the diagram a bit wrong. But I'm going to 60 makes the maths easier, right? So we're going to pretend that's the question. Right now, we are going to then plug in 60 for the angle. So we multiply that by 20, the magnitude, and we can work that on your calculator. 20 sine 60, sine 60 cos 60 is 0.5, and you multiply it by 20, and you get it's 10. So 10. Now we're only going to look at the horizontal components in this question, okay? That's what the question is about. It's a tug of war. So there'll be no taking off just yet. So the net force is, it's going to be let's see, 10 newtons pulling to the right minus the 20 newtons that Bono's pulling back, okay? And that's minus 10. So Bono wins this one, okay? So there's only, out of that 20 newtons of diagonal, only 10 is really pulling to the right, because some of that force is lost by being pulled up by Buzz Aldrin Lightyear guy. So Bono is the winner in this case. But we might just very quickly do a vertical example, just because I don't want to like neglect poor old sine theta as well. Okay, so yeah. So let's put Bono on a weighing scales, except put wheels on it, so there's no friction. The question's easy. And again, we'll use 60 because that's a good number. Okay, we'll make it an easy question. So he's flying off here to the right, I guess. We're not actually going to put in an arrow because you only put in an arrow in a force diagram when there's a force. That's just his direction. Right. Let's break up that let's break up that diagonal component. That's what we're doing today. We're going to break that up into horizontal and vertical. So cos for car along the horizontal, S for skyscraper, sky up the top, going up for vertical component. What do we do then? We I guess you could put in the magnitude. We're going to put that in, and the angle. We'll put that in for cos as well. And yeah, again, we would do that before, and it was 0.5, so we still know that. So I think it's going to be 200 times 0.5. Half of 200 is what? It's 100. You can just do that with a calculator. Great. Okay. So actually, that's pretty much the question over already, because we've done all the calculations. Now we just need to kind of figure out what's going on. So it's the vertical. We're not looking at stuff to the right. We're just looking at the 100 going up. That's a vertical. And the weight going down. That's vertical. Stuff on the right we can kind of just ignore. We're only looking along here. Okay. So it's 100 up and 600 down. So we subtract those two and we get 500. So that's the answer. That's what the scales would read. So if you're being pulled along by Buzz Aldrin pulling up diagonally at 60 degrees at 200 newtons, actually we've just worked out only 100 of those 200 newtons is the vertical component. That would be subtracted from your effective weight, and that would show up in the scales as your weight going down to 500 newtons. Easy weight loss plan.